Here's part 2 of 9.5 notes. Yesterday, you just worked on, or actually today, you worked on factoring the trinomials where the leading coefficient was 1, and now we're going to go ahead and solve the polynomial equation. Remember, the first step always is to set the polynomial equal to 0. So to do that, to bring over the 18, I'm going to subtract it. So I have x squared plus 3x minus 18 equals 0. Step 2 is going to be to factor. So I have my two binomials, and I know that I need an x in both of the first positions. And then I need factors of 18 that will differ by 3. So I can list them: 1 and 18, 2 and 9, 3 and 6. Well, the 3 and the 6 are going to be the ones that differ by 3. Oops, 3 and 6. And I need it to be a negative 18 and a positive 3. So to be a negative 18, I know that one of these has to be negative, and I want a positive 3. So to get a positive 3, I need the 6 to be positive and the 3 to be negative. And again, you can check it: negative 3x, positive 6x. That does give me a positive 3x. So once you're done factoring, you go on to step 3, which is solve. So I set each factor equal to 0, and I solve these linear equations. X minus 3 equals 0, so x was 3. X plus 6 equals 0, so x is negative 6. So really we're just throwing on one extra step from what you did earlier in 9.5. Let's try another one. So the first thing I want to do again is subtract the 24. So s squared minus 2s minus 24 equals 0. Now I'll go ahead and factor the polynomial, s and s. I want to think of factors of 24 that will somehow combine and give me a 2. In this case, I want a negative 2. Well, I know 6 and 4 are 24, and they differ by 2. I need it to be a negative 2s, so the 6 needs to be negative and the 4 needs to be positive. And again, I can check it. Negative 6s, positive 4s gives me a negative 2s, and a negative 6 times a positive 4 is a negative 24. Now I'm going to go ahead and set these both equal to 0. And s minus 6 equals 0, so s equals 6. S plus 4 equals 0, so s equals negative 4. In some cases, like the next problem, they're going to make you work at it a little bit more. Oh, I guess this is not the one I was thinking of. In some cases, they're going to give you a negative leading coefficient. And I talked to you a little bit about this the other day. The first thing I want to do is factor out the negative 1. And so when I factor out the negative 1, I'm dividing through everything by negative 1. And this is going to give me a positive x squared minus 24x minus 180. And I still need to have equals 0. I forgot to put that for the example. So negative 1 just comes along for the ride. And I still have an x and an x. And I know I need one of them to be positive, one of them to be negative, since I have a negative 180. And factors of 180 that differ by 24. 30 and 6 equal 180. Now I just put them down here, but if you look at this, that's going to give me a positive 30 and a negative 6. Well, positive 30 minus 6 is positive 24. So I actually have these in the wrong position. I need to go 6 and 24. No, silly. 6 and 30. That'll give me a positive 6x, a negative 30x, which then gives me my negative 24x. So we're good. And a 6 times negative 30 is negative 180. Next step, I set each linear factor to 0. Now the number 1 out here, negative 1, I don't need it anymore. If they're asking you just to factor, then yes, this is part of your solution. But if they're asking you to solve, you can drop it off now because it's not a linear factor, it's just a number. So now I go x plus 6 equals 0, x minus 30 equals 0. So x would equal negative 6 and x would equal positive 30. So again, it's not necessary that you factor out the negative leading coefficient, but I have found over the years that it's easier to factor if you have a positive leading coefficient. Here's the one I was talking about earlier where they're going to make you work at it a little bit more. So before we can actually solve this and factor it, I have to sort of build it up and then break it back down. So I'm going to distribute the negative 3. So that gives me s squared minus 3s minus 6 equals 4. Now I want to set it to 0, so I'm going to have to subtract the 4 from both sides. So s squared minus 3s minus 10 equals 0. Now I'm ready to factor. I have an s and an s. I know I need a positive and a negative because I have a negative constant term. Factors of 10 that will give me a 3 are 5 and 2. I need it to be a negative 3, so I want a negative 5 and a positive 2. And again, we can check it, and it does work. So now I set each factor equal to 0. So s plus 2 equals 0, s will equal negative 2, s minus 5 equals 0, s will equal positive 5. All right, and now, of course, we have the complementary story problem. A community center is building a patio area along two sides of its pool. So we have the pool here, and then this gray area is the patio. The pool is rectangular with a width of 50 feet and a length of 100 feet. The patio is going to have the same width on each side of the pool, so they're just calling this width x all the way around. Write a polynomial that represents the combined area of the pool and the patio area. So if I'm looking at the length, I know that it's going to be x plus 100. If I'm looking at the width, I know it's going to be x plus 50. And this equals 0. So they're asking me to write a polynomial. They're not asking me to write a polynomial multiplication problem. So I'm going to have to go ahead and FOIL. And when I FOIL, I'm going to get x squared. I have 50x and 100x, so that's 150x. And 100 times 50 is 5,000. So there's part A. Part B, it says the combined area of the pool and the patio should be 8,400 square feet. So I need to go ahead and set this equal to 8,400. Now I'm going to go ahead and set this to 0. So x squared plus 150x. And when I do that, I need to subtract off the 8,400. Gives me a negative 3,400 equals 0. And now I'm going to work on factoring this bad boy. I know I need an x and an x, and I'm really going to think about factors of 340 that will give me a 15. So 340, let's see. I think if I take 3,400 and divide it by 170, I get 20. So I can use 170 and 20. I need a positive 170, pull a 1 in there, and a negative 20. And if I check that, positive 170 and negative 20 gives me a positive 150. 170 times negative 20 is negative 3,400. So then I'll go x plus 170 equals 0, x minus 20 equals 0. So here x would equal negative 170 and x would equal 20. Well, algebraically, both of these answers work. In a realistic sense, I cannot have a negative width of this walkway around the pool. So the answer is only 20 feet. Okay, I'm going to go ahead and give you your assignment if you would like to start it tonight. This is 9.5 part 2, and it's page 586 to 589, number 21 to 45, odd, 59 to 61, those are your lovely story problems, and 74 and 78. I will tell you that in the assignment there are some area problems dealing with triangles and rectangles. I know that you remember what the areas are, but I'm going to put them up here one more time just in case. For rectangles, length times width, and for a triangle it's a half base times height. Alrighty, be ready to discuss these notes tomorrow.